Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. In this video, you're going to see about the lecture series of the subject 23 CST 201 Database Management System, Unit 3 Database Design. So topic 1 Dependencies and Normal Forms and Functional Dependencies. So topics for discussion: functional dependencies, Armstrong axiom, closure of functional dependency, minimal cover, non-loss decomposition and normal forms. So functional dependency. So functional dependency means, so the notation is A tends to B. So where A is the determinant and B is the dependent. So attribute A determines the attribute value B. For example, student ID tends to student's name. So student ID determines student name uniquely. So Armstrong axiom. So Armstrong axiom refers to the rule to infer functional dependencies. So there are three basic rules in Armstrong axiom. So that is reflexivity, augmentation, transitivity. So the rule for reflexivity is if y subset of x means, so all the elements should belongs to x. So augmentation, if x tends to y means then x is it tends to y is it. So transitivity means x tends to y and y tends to z, then x should also be a subset of z. So example, if student ID represents department and department represents HOD, then student ID must also be a subset of a HOD. So non-loss decomposition, splitting tables without losing information. So divide table, join tables back, original table. So example, if student ID tends to department and department tends to HOD, so join back, original table will get restored. So consider this example. So normal forms. So normalization reduces the redundancy. That means it reduces the duplication of the data. So there are several types of normal forms. So in first normal form, it is represented as 1NF. So the condition is each column has atomic value. So there should not be any multi-valued attribute in the entity table. So and also in second normal form, it should also satisfy the first normal form. So in third normal form, the condition is no transitive dependency. So closure of functional dependency. So set of all dependent attributes that can be determined. Example, A tends to B. A plus consists of all the elements. So the closure is represented by plus symbol. So that is A plus means, so it derives all the functional dependencies with among the given set of attributes. So the closure represents A plus equal to, it contains all the values of A, B, C. So it starts with initially the attribute A. So A tends to B means, so B is a dependent of A. So we can able to add the value B. So closure means finding all the attributes determined by the functional dependency. So minimal cover. So minimal cover simplest set functional dependencies. So it remove extra attributes. So remove redundant FTs, functional dependencies, and keep minimal set. So purpose, simplifies and cleans up dependencies. So advanced normal forms such as the Boy's Code normal forms, determinant is a candidate. So in fourth normal form, removes multi-value dependencies. So this is the example. In fifth normal form, it handles the joint dependencies. So let's summarize what we have seen in the today's video. We have seen about the functional dependency, Armstrong axiom, and a closure and minimal cover. non-loss decomposition, then normalization. Under that we have seen about 5 different types of normal forms including BCNF. So this is the question: which functional dependency rule allows us to remove attribute from the left side of the functional dependency? So out of this one, the correct answer is third normal form. So which normal form remove multivalued dependencies? So the correct answer is fourth normal form. So these are the few references. Thank you.